What is SAP HANA? Well, it's a relational database. So you go like, what? Just that? Relational database? Yet another one? Don't we have enough relational databases out there? Well, it's of course not just a relational database, but at its core, it's a relational database. So let's go back. A relational database. What makes it special? Well, it's fast. It's pretty fast. It's really, really fast. You could actually call it lightning fast. Why is it? How fast is it? Like how fast is lightning fast? Well, some random KPIs, and we have Mike Ikrit in the back who is heading HANA product management, and with SPS 6 maybe we have like already just cracked some of those records again. 100 terabyte system. Imagine 100 terabytes of data in a database. And any query you throw at that, any query, ad hoc, nothing pre-aggregated, no stored procedures for like really optimize how the query is processed. Something you could just randomly come up with. Never more than 2 seconds. Never more than 2 seconds. Usually in the like half a second area. Insert speed, about 1.5 million inserts, maybe we have better numbers already now, per second, per node. So a HANA system can consist out of several physical servers. And each of those physical servers has multiple cores and multiple CPUs, and every CPU has multiple cores again. So it's like a lot of computational power that we have here. It scales pretty nicely. Some customers have reported, here comes the Geico pitch, up to 100,000 times faster or more. So performance increasements of 100,000 over what they had before HANA. That means that a process that would take days to complete now runs in seconds. Of course, that only works out if the problem is like just totally ideal for HANA, or it works out if the technology they used before HANA, maybe let's say, I could really say an ERP system that talks to an Oracle database and has layers and layers and layers stacked on top of each other, and now you put the same logic actually into HANA database and it runs 100,000 times faster. That means that like stuff that was done in monthly batch jobs is now done on the fly when it happens. Customer loyalty programs, for example, like who doesn't get those stupid coupons in their email every once in a while. You could actually send people a coupon when they're shopping in your store. You could send the coupon based on what they have in their shopping cart and on their loyalty, because you can always compute it on the fly. It doesn't cost anything. It costs split seconds to compute that. So what else makes HANA special? That's like the observable stuff. It's really fast. I criticize HANA a lot internally, but the thing that I just can't argue with is that the thing is fast. Why is it fast? Well, first of all, HANA is an in-memory database. And it's a truly in-memory database. We write data to disk for durability purposes only. Disk is tape. All the data that we work with is always in memory. And that means that when systems grow, you need a lot of memory. Like a typical HANA server, a typical node that you put in a landscape, it's a 4U rack server, about the size of a hi-fi component, an older one, like the tiny little ones, not an iPod. It holds half a terabyte and 40 processors. Now that's a typical one. The bigger ones have a terabyte of RAM, soon 2 terabytes of RAM, and 80, 100 processor cores. That's a lot of stuff. And then we build landscapes out of these things, and like one of our biggest systems that we built now has like 250 nodes, 1 terabyte each, And we have multiple of those landscapes across the world. And this, yes?
So you have a 100 terabyte query and 500 gigabytes of memory. What's the...
Well, if I have a 100 terabyte query, I need actually even a 200 terabyte system, which means I would have to buy 200 computers
I can do the math at this point.
with a terabyte each and do the installation work of putting them all in one cluster. It's not, HANA is fast. I didn't say it's cheap. Well, we touched on it. It's also fast because it's massively parallel. It's massively parallel inside one server because a server today typically has multiple CPUs, and every CPU has has 10 cores usually, which a core is a new name for processor. Like when I grew up, there was a processor. Your computer had a processor. And now like one CPU has like 10 of these things built in, and they all function in parallel. So no time slicing anymore. It's just not necessary. A thread is a thread, and it runs isolated from all the other threads on a special its own computer, basically. Every CPU also manages a certain band of memory. So memory is close. It's actually really physically close, and it's like logically also close to that CPU, and is managed by that core. And you can do the math. If I have 80 processors and a terabyte of data, how much is managed by one core? So when we have a query and the main process figures out where data actually lies that is used to answer that query, it just spreads out to all the processor cores that manage the band of data where we actually think that portion of the answer lies, and it just spreads out to the cores. That's a nice thing about this declarative language SQL, that you can actually parallelize the execution without the developer having to give you any hints. Because what's really been hard when Moore's law just got over that tipping point where it's not the processor getting faster, it was like more processors in one single machine, developers had to work differently. Because if you still use your single threaded model, then yes, your computer can run more than your application, it can run multiple applications, but inside your application, it's all strictly sequential. You don't use threads, you don't get it for free. With SQL and HANA, you get the threads for free because HANA does it under the hood. You write your normal SQL query, the system decides how many CPU threads it want to throw at it. Of course, when you get an expert, there's also ways to tweak it, how you partition data and so on and so forth to get the bands. Massively parallel, it uses all the computational power it can get hold of, and there's a lot, like thousands, hundreds, of course, certainly in a landscape, maybe thousands.
Question. So if you have 100 terabytes of data, then when you get your amount of memory, do you have to get 4 times that, or how much? Like, I know HDFS does 3 copies.
The rule of thumb.
And there's space for indexes and things.
The rule of thumb is that we want double the amount of RAM than you have in actual data. But because of something that comes when I click the spacebar next, because we prefer actually column-oriented store for data that is structured, not for unstructured text blobs. Large text objects don't compress very nicely. You can zip them, but if you directly want to search in them, they don't compress very nicely. But structured data compresses very nicely, and as compared to, like, let's say, a text file where you have like a CSV file with all your data, you get easily a compression factor of 20. So I usually get more as compared to text files. As compared to other older databases, I don't want to discredit any of the database vendors, and they've made great progress with like also compressing the data in their row-based store. It's not the 90s anymore where databases organize the data in 4K long blocks, and like no matter how much you use, it's always 4K. And They compress very nicely, but HANA usually gets a factor of like 2 to 3 over a modern database, and easily 5 to 10 after an older release of a traditional database. So you have to factor that in. I have had to chuckle myself when we published the results of our petabyte benchmark that ran on a 250 terabyte system. And given the fact that you need to account for about 50% processing RAM that you need for processing the data, and only the other 50% you can use for the actual data that you want to store, that means that petabyte had to fit into about 120, 130 terabyte. And it fit, because it was a petabyte in the source system, and then it compressed very nicely. I think we had a question.
Is that an option, or is HANA optimized for analytics?
HANA is very optimized for analytics, but HANA can do way more, as we will hopefully see. It comes from an analytical background. If I look at the history of SAP HANA, it's a brand new product that has been engineered from scratch, which doesn't mean that every line of code has been written from scratch, but it has been engineered from scratch. SAP has a long tradition in both databases. MaxDB had several names. It was we actually acquired the technology in the 90s before I joined SAP, but it was known as Adabas before that. Maybe some of you remember that. I did. And then we had various names for it. At some point, open sourced it to the MySQL Foundation, which then got bought by Sun, which in turn got bought by Oracle. We didn't like that, pulled it out. Now it's MaxDB, or it was MaxDB. And the team, all their knowledge about databases and asset compliance and transactions and locking and all that stuff, all this stuff went into the product. Not all the code will, because MaxDB wasn't very parallel. It didn't deal with in-memory very well. But we also have an in-memory tradition. When I joined SAP, I actually didn't join in 2007. That's when I came to the US. I joined in 1999, and we already had in-memory technology back then. Of course, we were talking megabytes or hundreds of megabytes, but we had a product out there, the Advanced Plan and Optimizer, which gave you logistics planning across your logistics centers in the world, and it used a product called LiveCache, which was an in-memory extension to SAP DB, now MaxDB. So all the data was already in memory.
When you talk about the parallel processing, right? So is the network bandwidth is a bottleneck?
The network bandwidth is a bottleneck, and when you build HANA landscapes out of several servers, that in the end also need a certain layout for the file system, because yes, HANA needs a file system. You would actually have either a distributed file system or just write everything to a filer. The log volumes are actually usually we use SSD for it, for the database log. When stuff is written to the log and is confirmed to be written to the log, the transaction is committed. The writing to the disk happens asynchronously, so it's not blocking anything. And the writing to the SSDs is usually lightning fast, because we don't use we don't use USB sticks. We usually use Fusion I/O cards, which sit directly on the bus, so you talk to them just like you talk to your RAM, and then there's a little bit of an overhead for persisting the data, but it's really, really fast. So you write to memory, then it writes to an SSD or to the database log. Transaction commits, control is back to the client application. Then asynchronously we update the data volumes, and usually the data volumes sit on some distributed file system. And the suggestion, like the recommendation, if you don't follow the recommendation, you're out of support when you run into trouble. The recommendation is that you use 10 gigabit networks between nodes and to the file system, and at least 1 megabit lines to your client applications inside your local area network. We also, I will show you later, that we have cloud offerings for HANA, both entry level, tiny, cheap, not a lot of memory, but you would be no, you probably would not be surprised how much data you actually fit in 30 gigabytes. You like, try to fill that up with structured data. Yes, if you're doing videos and if you're crawling the internet, or if you're connected to the Firehose API published by Twitter, yes, then you fill up 30 gigabytes fairly easily. But if you have like an analytical app, a data warehouse, like some 5 years ago, a 30 gigabyte data warehouse was unmanageable. Or like only you need specialists to manage it.
Questions. If the size of the memory is smaller than size of the data, do you do the partial loading?
No. Well, yes and no. General answer, if the size of memory is smaller than the amount of data that you have, then HANA won't work.
Wait, what?
But it won't work.
It won't
but there's always exceptions to those rules. HANA doesn't, when you start it up, it doesn't immediately load all the data of all the tables into memory if you don't tell it to do it. You can tell HANA, okay, upon start, load everything in memory. Then you have longer startup times because it takes quite a while to, like, one server load a terabyte of data, or not a terabyte, a half a terabyte of data, load that from disk into memory. It takes a bit, so startup times are long, a few minutes. If you don't load all the data on startup, but you load it on demand, then it'll be good for a certain while until, like, just by using and playing with the data, you have loaded all the tables and all the columns of the table. You can actually load data by column. So if you have like a table with 300 columns, but you really only work with 5, and in, like, I don't know about you guys, but for SAP, this is a very common scenario that our customers have like very, very broad tables and they really use only a fraction of the columns. And then you only load those and ignore the others, let them sit on disk and rot.
So your recommendation is to do the capacity planning in the very beginning.
Do the sizing very early on. You can always add nodes, but adding a node is not for free. Like, it's not just that you plug it in and it just works. You need to, sometimes you want to redistribute your data because, like, you might have, like, you have 3 nodes and you have a very large table and it's distributed over those 3 nodes already. You add a 4th one. You want to get the things in balance. You don't want only, like, don't want the data to stay on those 3 nodes that are completely overloaded and the 4th node is idling. You want to redistribute, repartition the data. And that takes time.
So when you say redistribute, do you need to change the program or it's just automatic?
No, that's automatic.
It's automatic.
That is automatic. Question was that 100 terabyte of data sounds like humongous, and where do you actually find use cases for such large amounts of data? Well, I on 1 or 2 slides from now talk about other features that HANA has, like built-in text analysis. So you might pull in text data, like huge text data, tweets or Facebook networks. So this stuff grows quickly. I don't even know the number, like how many terabytes of data is created on Twitter on a daily basis, but it's huge. It's so big that I don't even remember the number. Then sensor data. Think sensor data. With pre-HANA 10 years ago, when SAP was big in enterprise software, what did we really have? We didn't collect a lot of data about our customers. We had their address and payment terms and stuff like that, maybe 100 fields that we kept about our customers. And then we had like sales orders. I sell you something. A sales order has an ID, it has a date, like a few administrative attributes, and then it has a list of products that you bought, like with a product ID and the description of the product and the amount that you bought, unit of measure, unit price, amount, tax. That's pretty much it. I think I described a complete sales order. That would work. Now, you can track so many more things. You can actually track where is the mouse in my web shop? Where do they hesitate? How long does it take to click? If you look into clickstream analysis on web shops, this stuff is usually written to files, and it takes a long time to process those files. And you don't find a lot of, there's a couple of expert companies that analyze those files for you, you will not find anything in those files because it just takes so long. Imagine you take all that data and you put it into HANA. Then you can ask questions, you immediately get the response back, you ask the next question based on the response. It's very interactive. So you can actually explore these huge data sets. Like remember, 2 seconds maximum for a 100 terabyte data set. And you ask it any question. How many like green? Yeah, if it's somewhere in the data, we'll find it in less than 2 seconds. The question was, why would somebody invest so much money in specialized hardware when you can actually buy a few off-the-shelf PCs, throw Hadoop or any other MapReduce option on it, and do your queries and data analysis there? It's because Hadoop, and yes, you were absolutely right with the suggestion that it depends on the use case. If I don't have a special use case and my use case is good for Hadoop, you're absolutely right. Go with Hadoop. Whenever you need this responsiveness, whenever you need to be real time and not batch, then Hadoop is not a very good answer. In Hadoop, you need to think carefully about what you want to learn, and then you let your nodes run and calculate, and then it's a batch process, and then hours, days, or whatever it takes later, you have actually taken this huge amount of data and created very little insight. Very valuable insight, but in terms of the amount of data that you create out of this huge set of data, it's very small. And after all that time, you might find out, no, that's not really what I wanted. It's not really what I wanted. So you do this whole thing again. Again, you change your algorithm, and you let it run again, and you wait. And if you're smart, you're of course doing it on a sample, and one might ask, why do you even shoot with Hadoop on it? Why don't we just use a sample and just put it in a text file and let one computer run on it? There are use cases for one and there are use cases for the other. There's a lot of big companies who find tremendous value into the fact that it can take seconds from the signal to reach the database to the insight that is created out of the signal. And you don't get that with batch-based technologies. You get that with real-time technologies. And not every use case is for that.
Wouldn't another answer be an SQL interface?
An SQL interface is another answer to that, but the number of SQL programmers in the world is actually not that significant, really. It is, if you ask me, it is an advantage, but that is an opinion. If you look at the data, like some 15 million Java developers, no, depending on who you ask, some like 3 million Ruby developers, or depending on who you ask, JavaScript developers in the millions, and database developers like who really do SQL for less than 1 million. My theory is that database admins who do a lot of SQL just don't tick the developer box in those questionnaires, and we actually have a little bit of a data problem there. But that is really just a wild speculation. I would assume it's more. Okay, when I speak about a node in HANA, it's like really one server in a larger landscape. In a way, it can be mapped to AWS, although we do not really suggest to virtualize any of that. Like a node is really a physical server. HANA can be virtualized. It runs on virtual machines. It actually does run on AWS. But, well, the analogy is like more with a Hadoop cluster. A node is a machine in a larger landscape. A node is one physical computer. Like this could be a node if it wasn't a MacBook, because HANA doesn't run on Macs. A node is a physical computer. It is not commodity hardware. It's actually, we have actually very tough requirements towards our hardware partners. But like, of course, these computers are assembled from commodity components. Like everything is built in Taiwan. It's like just normal Kingston RAM, or it's normal Intel processors. Like everything in HANA is Intel based. Intel optimized their processors. We have like machine instructions in the processor that use one CPU cycle and execute something that HANA needs. So there was like a joint project with Intel. But it's normal Intel processor, Westmere processor, or what's the current generation, I don't know. A Westmere processor that you can buy off the shelf. You can go to Fry's and buy one. When you buy a HANA server, we actually want to certify the configurations to make sure we get good performance, high throughput, the memory to CPU ratio, we give recommendations about that. The disk layout, we give recommendations about that, so you can actually write and read from and to disk, to and from disk at high speeds. You might ask, why is this important? It's important for failover scenarios when you have to, like, out of a sudden you have to page a half terabyte from disk into a standby server. That can take long if your disk layout is crappy. So we do certify, but everything is commodity hardware. It's just the vendors that we work with, IBM, HP, Cisco, pretty much everyone except Sun, I guess. I heard we have 11 hardware partners. I didn't even know there's 11 server companies in the world.
So does every commit involve a write to disk?
Well, yes. Yeah, but the write to disk is asynchronous. As I said, it doesn't block, the control goes back. We don't wait until the data is written to disk. So a HANA system has like this huge band of memory. RAM. It has an SSD subsystem, and it has disk. So that's what we have in the server. Actually, the disk, usually of course we can have the disk in the server, but usually you don't have it inside the server. You have it somewhere connected to the server via 10 gigabit network connection. So that's what you would usually typically do, but there's no reason if you have a single node HANA system, there's no reason why the disk shouldn't be built into the server. So that works. Like write request comes in, it goes to memory. Actually, it goes to a special delta area in memory first, and from there we write it into the log files. That's the database log volume. That's the instructions to update the database. It's not a log file that sits on, like a web server log file that sits on this. It's the database log. Every modern database maintains a log file that is the instructions how to update the data. It's not the change data, it's the instruction to update it that goes there. So when this is written to disk, the transaction actually returns and says committed. Nothing happened here. It's only written to disk. And now periodically, the log is applied to the data that sits on the disk. But that's a second thread that is completely independent from what happens up here. Because once we have it, SSDs are persistent memory, we could have a power failure, an earthquake or whatnot, data is persistent. So when the database crashes, and this hasn't happened yet, at the next startup, it will actually apply the log to the disk. That's the first thing the database does after a failure. It looks, okay, what hasn't written from the disk into the, from the log into the disk? It gets so complicated, I'm getting stuck.
Is that log redundant to eliminate single point failure? Let's say you committed something to the log.
Now it actually is.
Okay.
Is it or will it be?
It is.
It is, right?
So for failover of many nodes in the cluster, in fact, it's not local SSD, we'll be using network attached storage. So EMC, NetApp, Hitachi storage, very, very high speed, very high end, and this provides the redundancy to the log on failover. If it's a single node and rack server, obviously you have a single point of failure. IBM has taken a different approach to, say, Fujitsu uses NetApp. IBM has GPFS shared nothing cluster. So they have built in by rack servers with local storage redundancy.
They all are a little bit different, but SAP has a couple specs that we give them. CPU to memory ratio, data throughput to the log volumes, data throughput to the disk volumes. Like they have to meet certain criteria. Meanwhile, they can even tick off on them themselves. So we don't test all the configurations in our labs anymore. If it's important, we do, but you can actually sign off as a hardware vendor. But you also take the responsibility. While we're at it, I can actually just mention it here. SAP also offers HANA in the cloud. I actually did slightly touch on it, but I kept stuck on the tiny HANA on AWS things. We actually offer something that is called the HANA Enterprise Cloud, which are those huge servers purchased by SAP. And you can actually subscribe. You can buy computational power and storage on a subscription-based model. And yes, we had the question before, I don't remember who asked the question. Yes, you will have to think about your network if you really want to, if you really want to send gigabytes of data per day or whatever time span over a network line, then you better make sure that it goes over the network line. Well, the first customers we see for HANA Enterprise Cloud, or where it actually came from, is SAP customers who already host or have outsourced the operations of their ERP and BW systems. So who sit on some 20 terabyte of data that is already not in their data center, it's on some cloud provider's infrastructure or hosting provider's infrastructure. Cloud and hosting is really that different. For the infrastructure provider, it's the same thing. The only difference might be self-service sign-up or not, or what the subscription model is. It's more a business difference than a technical difference. So both need to operate a data center as efficiently as possible. So, and those customers, they were reluctant to buy HANA and pull everything back into their data centers, because the usual business model for HANA is that we sell it as an appliance. So you go to one of those hardware vendors, there's a lot of choice, and you tell them the size of HANA system that you want, and if you want a distributed one or a single node system, and then they sell you the machine with HANA pre-installed. And they deliver it to your data center, and they plug it in, and there's a few configuration steps like following your hostname policies and securing the system and letting it talk to all the other systems that you have in your landscape, and that's it. Then they leave off. From SAP, you actually only buy the license, and the whole thing is sold as an appliance. But if your business systems are already in the cloud, you don't want to buy a database that sits in your data center. So we say, okay, we have to put the database in the cloud too. And that's what we've done now, and it's also, well, if you do the math, and it is an expensive, its hardware costs are high, it's expensive, and license costs are comparable. It's not that you buy 200K for the hardware and then we give you the license for 20. SAP takes some money too. And so it's expensive, and so you might want to go for a subscription-based pricing model if you're not quite sure if that really is breakthrough technology for you, or you just don't want the hardware and operations in-house, because you're just getting rid of all that stuff and you're just putting it in the cloud, and here comes this appliance-based thing and you want something on the cloud. Then we can give that to you, and then your systems talk to it again on a 10 gigabyte network inside the cloud provider's data center, and you only have to make sure that you get the front end right. But one of the ideas about HANA is that you put the data, this massive amount of data, you have that in your database, and now classical 3-tier architecture says when you want to process the data, you put an app server on top of that. The app server requests all the data it needs to do the computation, which can be a lot of data. Okay, give me the total amount of all sales orders in the systems. Yeah, well, you have to touch all sales orders, so you have to transfer all sales orders to the app server, and then you have billions of sales orders that can take a while, even with a fast network. And then the app server will do the math and write the result back to somewhere or put it on the UI. But the result is usually like something very small, whereas the original data that you do the computation on is big. With HANA we say, okay, the code is usually smaller than the data, so why don't we move the code to the data rather than the data to the code? So a nice chance for me to actually go to the next slide. Because HANA is a relational database. Yes, it's fast, it's massively parallel, it's column oriented, it's in memory and all that stuff. Yes, but it's not only that. There's more. We build a lot more functionality inside the database that you would typically not find in the database. Some databases have some of those features. Others have other features. Some databases have features that you don't find here. Then you will probably find them very, very soon. One thing that I had on the slide I needed to take out because the team disappointed me is support for geospatial data, and not only for geospatial data, but also the math, which didn't make it in the currently available release, but will be available extremely soon. Like it's done, it's implemented, probably didn't pass the QA. I don't know, but they promised one of the next updates of HANA will have support for geospatial data types. And then you can actually, when you read a tweet and it's positive or negative, because you do find sentiment analysis here, you can actually, the database can tell you this is a positive statement about your product. And you don't need to extract it and use Lucene or anything else in dictionaries. It's all built in the database. You just say, okay, give me all the positive sentiments in this column. So you could also like join that with a location and say, okay, in a like let's say 50 miles radius around Palo Alto, what do people think about HANA? And when you go further, does this change? You could do that. Not with the version that is available right now, but with that one of the next updates that I expect to be released within the next weeks. So, what else do we have? We have a library of functions that you can use to build business software. SAP, traditionally, we are a business software vendor, so we think, maybe that's arrogant, but we think we kind of know what functions enterprises need when they do financial accounting, when they do HR, when they do sales and whatnot. I listed a few very typical. The list is huge and it's all documented on help.sap.com. So you can do currency conversion on the fly. So what does that mean? You don't need to clean up your currencies while you're importing the data or while you're creating the data. There's no need to have like a reporting currency and then the currency in which you actually do the deal with your customer when you're an international company. You always do it in the currency you want to. And then when you do your query, we do the currency conversion on the fly with the correct currency conversion rate. All this stuff sits in other database tables, and there's just one function to call, okay, I want the amount in dollars. Where amount in dollars is greater than $1,000. You can do that. And you don't have to store, you can store the original data in euros and still ask for the amount in dollars. Moving average, very hard problem if you want to use standard SQL. Moving averages are a hell in a declarative language. You need cursors. Otherwise, you don't get performance. It's recursive, and recursive not possible in SQL. So you find all sorts of tricks. HANA has a function for that. You just call the function. Year-over-year comparison, something every business company does. Year-over-year compare, quarter-over-quarter. How much better am I doing than last year? It also has a math library. We call it Predictive Analytics Library, which is a little bit of a stupid name. It's some mathematical algorithms. Some of them are statistical. Some of them are just purely numerical. Some of them are very highly sophisticated. K-means clustering is not highly sophisticated. Linear regression a priori I would also not call highly sophisticated. We have self-organizing maps, which is like neural networks on steroids. Since I graduated from university, I have this big book in my bookshelf, and I never cracked it. But you have a set of about 30, 40 functions, and you will probably find the one you're using the most, built into the database, and you can actually apply those functions to the data in the database in memory. No need to copy anything. You make it part of your query. I do what I frequently do, and I even do it on HANA, although it's like not a big data set of a few million rows. Like it's just tiny for HANA. It's a few single gigabytes, so not even in the tens of gigabytes. A few million rows, HANA usage on the cloud. And I do ABC analysis. And ABC analysis is just a function I call in my query. I just tell them, okay, the percentiles, how big do I want them? The A, B, and C percentile, how big do I want them to be? And then the database replies back with like, this is your A segment. These are your A HANA users. That's pretty neat. So you would have to program a lot of stuff on your app server to get this data. Whenever we don't find a function, HANA integrates nicely with R. For licensing and legal reasons, we cannot bundle it because R is under open source licenses that are contagious and would make HANA open source if we bundled it. HANA is not open source. But it integrates nicely with R. It's a half-hour setup if you know what you're doing. If you anyone doing math and statistics? Yeah, we have a few. If you know how to set up an R server, you will find out how to connect it to your HANA system in absolutely no time. And then it's actually talking to the data directly. You can write R functions inside HANA. What else do we have? Yeah. Let me start here at Text Analytics Engine. I start here, I continue here because I already mentioned that. HANA can understand text. It can do word stem analysis, so if you search for something like, give me everything that contains developer, it will also find you developing, all this stuff, because it has the same word stem. It also does sentiment analysis. So we have a built-in dictionary in a couple of languages. English was the first one. We have a couple more. We just added Chinese. And it can tell you if certain portions of your text are positive or negative, or strongly positive, strongly negative. It even detects smileys or Twitter hashtags. It knows this is a hashtag. It knows this is a Twitter handle. It knows all that stuff. So you can query. You can load a massive amount of tweets in your system, and we've done that in the labs. You load a massive amount of tweets, and you search for, give me all the tweets by handle, whatever, Larry Ellison. You won't find a lot. So it just finds that in the tweet. You know, like you do MapReduce. Usually you do MapReduce on Twitter data. You have actually already Twitter does that before they publish the API. They take this whole. There is not a lot of structured data in a tweet, but they take it and they dissect it, and when you call the API, you actually already got, okay, this was a reply to that tweet, and this was this, and this is here's all the list of all the hashtags is nicely extracted, so they already parse into something way more structured. In HANA, you just load the tweet. You do the dissection of the text at runtime when you have a question. No need to do asynchronous MapReduce. You just don't need it. And of course, if you load all of Twitter, then you will need it. But if you load a few billion tweets, maybe whatever, 2 months, 3 months of Twitter, you don't need MapReduce. You just do text analysis on the fly. You find everything that has ever been said about SAP HANA. You know by whom. Was it a positive or negative statement? You know everything. The question was, when you have your data distributed among all those nodes, how do you combine it without doing MapReduce? It's not a distributed database we're talking. Yes, it's various servers, but logically this is one database instance. And you have to think about computer architecture as it is today. Even inside this box, This box is really for computers, for completely independent computers. And the next generation will probably be 16 completely independent computers. And they talk to each other, they communicate on the bus very fast. They don't need to, like, when one computer inside this box wants to talk to another computer inside this box, it doesn't go over the network or some other external protocol, it talks on the bus. They're all connected with a high-speed connection. But it's various independent computers. Now we take some of these boxes that have various independent computers in them, and we assemble a larger computer. You know, you probably have read about all those supercomputers with so many exaflops. This is not a single computer. This is a cluster. And like one logical HANA server, that's why I said, yes, we say they need to be connected via 10 gigabit network connection, these nodes. They need to write on a shared file system. It could be a filer, it could be GPFS in case of IPM. Every single node in the landscape needs to mount the data partition under the same path, so it's really truly shared. It's one big computer. It's just the boxes that are different. So it also doesn't work in a WAN. It's not for a wide area network simply because you don't get the speed. If we had a landscape that would use dial-up lines and be one node in Peru, one node here in Palo Alto, one node in Shanghai, yes, then you would need something like MapReduce. You can build those things out of single HANA systems or landscapes and let them talk to each other via replication protocols, even Hadoop. You can even let them talk via Hadoop. But when I speak of a HANA landscape, then I really mean one logical server. Just if you look inside, you do a double click on the logical server, it's really like 20 machines. And you do a double click on the machine, then it's like every machine has 10 CPUs. And you do a double click on the CPU, then every CPU has 10 cores. So it's all distributed. That's what I meant with massively parallel. And yes, we assume that they're all in the same local area network. Most of the time they sit in the same rack or in the same aisle if you need more than one rack in a data center.
Can Amazon EC2 instances be configured to meet your requirements?
Yes, we have. Actually, we sell something called HANA 1 on Amazon EC2. It uses the cluster compute instances, which use a bare metal hypervisor rather than a software hypervisor. So you really get, when we give you 8 virtual cores, you're really talking to 8 physical cores, pretty much directly. That's what Amazon guarantees for EC2 instances. Currently, it's just licensing issues. It has nothing to do with the technologies. We've done more in the lab. Currently, we limit it to the 60 gigabyte instance types, although Amazon already supports 250 gigabyte in a single node, and we also don't allow HANA 1 customers to build clusters out of that, which would actually be pretty ridiculous if you don't get the 256 nodes, so you take 4 60 gigabyte nodes and put them in a cluster. That doesn't make a whole lot of sense. You would just go with one bigger instance. You scale up as long as you can, and then you scale up. So it would technically work. We've done it. We don't allow it because, quite frankly, we haven't figured out a pricing model for it yet. We don't really know where it ranks as opposed to the smallest appliance or our upcoming low-end enterprise cloud offering. So it's really just more a go-to-market issue than a technical issue. And I'm pretty sure it's not a question of if, it's a question of when.
Excuse me. I have a question about Math Library.
Yes.
So the thing is, like, you have a product for SAP Lumira, which does the analytics and showcases the visual analytics, and which runs on SAP HANA too. So my question is that, can the Math Library, and it also has a predictive analytics, so
yes,
how that will be integrate the Lumira analytics? In the Lumira, how I can call the HANA predictive analytics? If you have
you can do that. Lumira can connect to for the 0.001% of you who don't know SAP Lumira. It's a visual analytics tool that we sell. Actually, it's fairly low cost. You can, like, if you remember Lumira after this talk, you can jump on the internet and get a 30-day trial. It's pretty nice. It helps you create visualizations of data, and it can talk like JDBC and ODBC to any database, but it's also like it connects very nicely to SAP HANA. And you can just like visualize what's going on in the system. HANA can be used to build a star schema, and you can build those typical bar charts and pie charts, or you can build like more sophisticated analysis, heat maps, all this stuff. So that's SAP Lumira. How would you run the predictive, and how would you call a predictive analytics library function? Let's say you do like linear regression and you have like a line chart and you want to have a trend line. Easy as that. You would use a regression algorithm, maybe like you just want a line, trend line, then you would use linear regression, or you might use splines to do something like closer to the original data, which you then could use to extrapolate and predict the future. You would have to wrap the stored procedures in a calc view, and then you can expose it. And I have code that ran until support package 5, and now it breaks, and I need to get it back running, and then I'm going to post a blog about it. So you can do that. The trick is you expose your stored procedure as a calculation view, which is just calc view that has an interface and it calls the stored procedure, and that's it.
Question. So all of these things like the math library and R integrations, the data that works on has to be in relational format, or it can be, other
Yes. Yes and no. The data should be in relational format. Mainly. Then there's the text analysis engine. You can build, you can have, in a table you can have a file that is of data type character large object. So the database knows it's textual data, and it knows it's large. There is a size limitation, I think 65K, or like there is some size limitation. You cannot fit Google into one field. But when it's a table with just one field, that is fairly unstructured. Yes, you're kind of bending the rules here, and you're using arrays to store unstructured data, but you can do it. It's not a native JSON database or anything. It's not a NoSQL database, but you can use it to store, let's say, semi-structured data. It started out as a purely relational database, and it got more features, and now I would call it semi-structured. One more thing that it can do, it's ANSI SQL 92 is at the core. So any ANSI SQL that you run will execute on HANA. But most database vendors, well, no database vendor speaks ANSI SQL only. Everyone has put some bells and whistles on it. ANSI SQL doesn't even have blobs. Everyone has put something beyond the standard. So don't think about like migrating an application that runs on Postgres today to HANA. It's just like move the data, create the tables, move the data, and change the connection in the JDBC driver. It's not like that. It's not that easy. It will be possible to migrate it, but there's manual work involved because nobody does ANSI SQL only. Everyone pretty much does it. Nobody does it only. A real application uses proprietary features of a database vendor no matter what. So migration will be a little bit difficult, but you can do it. One more thing regarding unstructured or semi-structured data. I just wanna tell you, as long as the thought is fresh, and is that HANA gives you a proprietary extension to ANSI SQL. And the clause, when you define a table, is with schema flexibility. Now, this little thing does something very nice. It allows you to store data in columns that are not defined. Store data in columns that you never defined to be part of the table. And when you store, let's say I have a table, customer, ID, and name. And one customer tells me, I'm 50 years old. Then for that customer, I store ID, name, and age. If I'm not a complete idiot, I store ID, name, and birth date. But let's say I'm an idiot and I store age. The point is that I never told the database that age is a column of that table. I just told it, hey, I actually might want to store more than this. And then you can use it to query the database. It's a column table naturally. Every column is indexed. You don't define indexes on HANA. You just don't need it because every column is indexed anyway. So you have an index. You can find, give me everyone over 50, just like that, even if it was never part of the table definition. And then you can move data around. You might start and you see, oh, this data is this column, this is dynamic, is very sparsely populated. I don't get anything useful out of it, delete, drop it. Or you said, oh, it seems I forgot something in my data model. Like 80% of the data that comes in actually uses that column, although it's dynamic. Then you make it a static column, and you can just change that. You alter the table and make a dynamic column a static column. Slight performance gain. A slight performance gain. We have more questions?
On your math library, what else do you have in the way of clustering or sophisticated forecasting algorithms?
One of those links that is here is into help.sap.com, and here we find the documentation of the Predictive Analytics library. And no, it doesn't run on HANA. It was that fast because it was cached locally, which is totally not necessary with HANA anymore. And you could just, if it's not too far, you could just see what we got. Auto clustering and classification algorithms. It is actually the libraries. The library has been, we have seeded it with about 15, don't push me too hard on the number, but about 15 algorithms about a year ago. And then customers who were using the library actually were able to give us feedback on what's missing. So this has grown based on demand. We could do more of this. It is not cheap for SAP to implement an algorithm because it sits inside the database kernel, not inside the kernel really, but it sits inside the database code. It talks to the data in memory via internal protocols. That's why it's fast, but it's also very difficult for us to implement algorithms. And as a customer, you couldn't just build your own. That's the general rule. There's always exceptions to the rule. If you talk to us and you paid us a lot of money, then we will find a way. But the general rule is that this is not an open library. This is something that SAP builds. It's a fairly large list. Just feel free to explore. The document doesn't only tell you what we have, but as also code samples that you can just copy paste into your own HANA systems and run. It will create the entire context of how you use the algorithm. It creates some sample tables, fill some data in it. Of course, it's small, but it's a pretty good document.
Can a user write custom routines to put into the server? Maybe take some of these out and put their own routines inside?
Only when you use the R integration. Then you can write your own algorithms in R. It is not as fast because the R server is a standalone process. It doesn't run inside the database system, and it's fairly fast because it talks to HANA via an internal protocol. It doesn't duplicate the data. It sits on shared data, but it is not the fastest way to use HANA. It is definitely the fastest way to use R. There is no more start your program last thing in the evening and come back in the morning and see if it worked. This just doesn't happen. 2 documents down from the one I just showed is the R integration documentation, and it tells you exactly what the prerequisites are, which version of R to get, what libraries to install before you even try. So if you want to give it a try, we offer HANA for free, for absolutely free on the cloud for up to 30 days paid by SAP. afterwards, you can continue on Amazon Web Services or a number of other cloud providers, and you pick the cloud provider based on the pricing model, that seems most attractive to you. 30 days you get for free, sponsored and paid by actually our group. Then afterwards you get the license for free. Like from a license perspective, HANA is free for development. You can build whatever you want, you can take it to market. If you find a HANA customer, you can sell it to them even without SAP. If you have something interesting, you can join the SAP HANA Startup Focus Program, get hand-holding, support, access to internal knowledge, access to resources, some even access to money, the marketplace, and then you can sell your app through SAP. But you can jump on your own trial, try all those algorithms, try the R integration. You can pretty much get a fully functioning HANA system. The only limitation is memory and of course performance. It's not one of those systems where you put 100 terabytes into and you get sub-second or less than 2-second response time. This is standard commodity cloud virtual systems. And there's various choices. One of the links is developers.sap.com, easy to remember. If you don't remember if it's developers or developer, it's both, and sap.com/developers will work too. Anything that has somewhat SAP and somewhat developers in it will probably get you to that page where you can get access on HANA to HANA, and then we have all the documentation. We have a lot of PDFs. It's too much to read for a single person in a single lifespan. If you prefer video, there's hundreds of videos to watch. While we are here, I just put on what you need to get started. You really need to have solid SQL skills because that's what everything is built around. You can use HANA only as a web server, but that would be just throwing money down the drain. It's a reasonably good web server, but if you could go for price performance comparisons, then it's as a web server not very attractive. If you prefer video content over reading a lot, you go to academy.saphana.com or open.sap.com, where we actually offer training courses, online courses every once in a while. We just finished one, 40,000 participants, more than 10,000 took the final exam, and it was a 6 weeks course. So that was pretty big. And your own systems on developers.sap.com/HANA. Is HANA also as a web server? So when you build all your tables and data and stored and user-defined functions to really get your numbers crunched in real time, in memory, with a lot of computation pushed all the way down to the database level, all the way down to the data. Then you want to put a nice UI on top of it, maybe a mobile UI. SAP HANA contains a little web server that you can use. You can write server-side JavaScript. It's not Node.js. It's not callback functions all over the place. It's a server-side JavaScript engine that just executes JavaScript and has an API to talk to the database, talk to other web servers out there, send emails, and all the stuff you might want to use in a web app. Why did we choose JavaScript? I think mainly because it's not Java and it's not ABAP. You can also connect from all the popular development environments. If you don't find yours, I don't find Ruby, and I like Ruby. I actually gave an ACM talk 5 years ago about Ruby, and I still find that. It's embarrassing. But if you like Ruby, you can build your own driver, because we actually published the driver spec, the technical protocol that HANA speaks on the network layer. So you can always build your own drivers if you don't have one for you. With that web server, you can build HTML5 apps. You can build HTML, JavaScript, CSS apps. We even have our own HTML5 library toolkit pre-deployed to the database, so you can build applications. This is one application I built myself. So this is on my iPhone, hard to see, but it runs on HANA. And it does charts and like all sorts of stuff. And it's all running on HANA. There's no app server in front of it. There's nothing runs on my iPhone except some JavaScript that is part of the web page. It's all HANA. And one thing I particularly like about the XS engine, I'm not a huge fan of server-side JavaScript myself. I actually use the Python DB API a lot. But one thing that you will just love when you do web apps is the possibility to expose a table or a view or a model, whatever you've built in HANA, stored procedure, you expose that with an HTTP interface. For a table, it's even a CRUD interface. Create, read, update, delete. A full web-based interface that's based on OData. OData is in turn based on Atom. So this is really like just an open web protocol. It takes you one line of, I call it line of code, it's actually declaration. If you want to navigate a table hierarchy, it's one line per table plus one line per relationship between tables. So fairly easy and fully declarative. And that's all it takes. And then you have an XML or JSON interface to your data.
It has security.
It does have security, yes. It does SSL, of course, if you wanted to.
Login.
It does login. It has form-based login. It has SAML authentication, which is very important for our SAP customers. And it also supports basic authentication, pretty much for development mode. Kerberos certificates. Kerberos.
Identity management.
Yeah. So no OAuth yet, but we keep pushing. The question was, do we support large data types? Yes, we have character, CLOBs, and blobs with certain size limitations, but you can upload a video in like a movie.
JDBC or DBC connection? Or?
Yes, you can also do that by the JDBC and ODBC connections. Network bandwidth is pretty much your bottleneck here, but the drivers support everything.
And you should mention maybe ODBO.
Yes,
MDX.
ODBO if you come from MDX, if you come from the analytical world to talk star schemas all day long, then you will probably also use the MDX drivers. There is a special driver that just embeds nicely into Microsoft Excel, and you just do your pivot tables against a HANA database, and you do absolutely no code, absolutely nothing. It's just you just connect to your HANA database. It shows you all the star schemas that you have, and you slice and dice in Excel. Lightning fast, because the actual data is never transferred. It's only the results of the calculation. Actually not. If you look at encoded genome data, it's a sequence number and a floating point number. That's pretty much what you have. And you have like huge tables of that. And when you do genome analysis, you actually just calculate deviations from a reference model. So that is something that works very nicely in HANA. We actually demonstrated a running application on HANA at our customer conference, Sapphire, in May. And that has been built together with like medical and bio experts. And you can actually get your genome analyzed for, I think they mentioned $3,000. The whole healthcare topic is something where we have actually set up an entire program for. So we have people who only work on healthcare use cases. Genome sequencing is one of the popular ones because the vision is that your doctor would just tell you your predispositions while you're at the doctor, not like 2 weeks later in the mail or the phone call. We actually think, and again, it might come across a little bit arrogant, but what the heck? We think we have something that is years ahead of the competition, and they're slowly catching up. It's kind of funny and exciting for us to read that every major database vendor now puts stuff in memory. About 2 years ago, they told us we're complete idiots for even trying that. So as far as competitors go, they were right. It's not easy, and they will find that out. And we've learned our lessons, and we have a product out there that is strong, and we don't fear any competition right now.
Volt is a competitor in memory, built to be in memory by Stonebreaker and Company.
We know it. We have a bit of a unique offering with all the stuff that we have on the slide. It's not just a fast database. It is a very fast database, but it's not just a fast database. And we see in the market we are competing in, that is mainly an applications market or an application platform market. So people want to build applications to extend business applications or to make stupid marketing slogan, the road run better. We are not really in the consumer world. We don't want to be the database on the Facebook. But we certainly would like to be the database on the Salesforce. Unfortunately, that doesn't happen either.